Let's look at this derivative application where we look into some word problems and do some average velocity calculations and instantaneous velocity calculations. So we want to remember that average rate of change or average velocity means the slope formula. So if something asks for average change between 2022 and 2024 or something like that, we would use the slope formula. F of B minus F of A over B minus A. If you see the word average and any sort of change word, then you're going to use the slope formula. If you're asked about change and it is just at one instant, how fast was it changing in 2021? You would take the derivative and plug in. So change at an instant means take the derivative and plug in. So I know word problems can be pretty intimidating, but for calculus, it's kind of nice because you really have average, which is slope, or instantaneous change, which is derivative. Another option is if there are no change words, it's not asking about any sort of change at all, average or instant change, we're just going to plug into the original function. We also want to remember with rates of change, they have 2 units. So like when you drive, it's in miles per hour. When you walk, you can measure that in feet per second. We can talk about dollars per decade or something like that. These should have 2 units for either average rate of change or instant change versus the plugging into the original function is just going to have 1 unit. Just the output unit versus 2 units is going to be the output over the input. Thousands of dollars per year or something like that. So looking at this first example, we have a chain pizza restaurant is installing pizza warmers into their fleet cars. The number of fleet cars with pizza ovens installed is given by this V of t. Here's our function. V of t is measured in thousands of vehicles, and t is measured in years, where t equals 0 corresponds to 2012. So first of all, we want to note our units. Thousands of vehicles and years. So tell me how many vehicles are and I'll tell you what year it is, or vice versa. We got to figure out what do we plug in, what do we get out. Well, V of t, we're plugging in time. We're plugging in years, and depending upon the years, we can tell how many thousand vehicles there are. So tell me what year it is, and I can tell you how many pizza warmers that they should have installed. And time 0 corresponds to 2012, when they started this project, it seems like. So the first part says, what was the number of vehicles with pizza warmers in 2015? So what t value is 2015? This is where it's totally okay to count on your fingers. We have 0 fingers up for 2012, 2013, 14, 15. That would be 3 years later. So we want to plug in V of 3 into the original, the slope, or the derivative. We're plugging in 3. It doesn't have any change words. It doesn't say on average how fast was the number of vehicles with pizza warmers changing between 2015 and 2018. It's not asking about average change between 2 years. It's not asking about change at an instant. We're just asked what was the number. So we're plugging in to the original function, V of 3. We're going to plug into our function here, 0.7 e to the 0.12 times our t is going to be 3. Some calculators you might need a parentheses around the whole exponent there since there's 2 things being multiplied. So plug this in on your calculator, find your E button. You might have to hit second ln to find it. And you should get 1.00330. It just keeps going. What are our units here? We plugged in years. the third year of installing pizza warmers, and we're getting out thousands of vehicles. So this is 1,000 vehicles. So 1.0033 thousand vehicles. I think it's actually easier to think about this if you multiply it out by 1,000. So if we move this over 3 decimal places or multiply it out by 1,000, there's going to be about 1,003 vehicles with pizza warmers in 2015. Just over 1,000 vehicles had pizza warmers installed, ready to do some deliveries. The next part, again, I'm deciding, do I plug into the original again because it doesn't ask about change? If it says average change between 2 years, I'm going to use the slope formula. And if it asks for change in a specific year, just one instant, I'm going to take the derivative and plug into that. So it says how fast was the number of vehicles. So first of all, how fast, that indicates some change to me. The number of vehicles with pizza warmers changing in the beginning of 2015. So definitely change, not going to plug into the original. Are we talking about slope or derivative? Well, it doesn't say average change between 2 years. It's just change in 2015. We're going to take the derivative to find that change in just 2015 alone. Were they getting more vehicles with pizza warmers in 2015? Or maybe the derivative could be negative, which means the number of vehicles was decreasing. Maybe there's something wrong with the pizza warmers and the amount out there is going down. So we're going to figure that out by taking the derivative of the function we were given. So looking up here, we have v of t is that 0.7 e to the 0.12 t. Well, we want to take the derivative of this, 0.7 e to the 0.12 t. So we need to remember how to take the derivative of something with an e to a power that's not just x. So I want to remember if we have the derivative of like e to the x to the fifth. How would we take that derivative? Well, we'd say the derivative of the power is first. So derivative of x to the fifth is 5, x to the fourth. Derivative of the power times e to the original power. So we want to remember this rule here and apply it to our problem. So we're going to take the derivative of this, so we'll call it v prime of t. We're going to keep that constant multiple 0.7 and take the derivative of e to the 0.12 t. So we'll start with the derivative of just the power, just like we started with the derivative of x to the fifth would be 5x to the fourth. We're going to follow that same pattern. Derivative of the power, derivative of 0.12 t is just 0.12. And then we have e to the original power. There's some review of e to a power that's not just x. Derivative of the power times e to the original power. We could plug in just like this, or if we want to take a second and multiply out these constants, we could. V prime of t. 0.7 times 0.12 is going to give us 0.084 e to the 0.12 t. There's my derivative. I can plug in any year to this, and that will tell me how much we're changing by. How many more vehicles or many less vehicles, could be positive or negative, we haven't plugged in yet. It's how fast the number of vehicles with pizza warmers is changing. So we want to figure out for 2015. We know they already had 1,003 cars with pizza warmers, but how is that going to change that year? So we're going to plug in v prime of 3, which is 0.084 e to the 0.12, and we're going to replace that t with a 3. Which gives us, plugging into my calculator, I get 0.12039967. Let's just keep going. I remember this is in thousands of vehicles. If it was in billions, I probably wouldn't multiply out by 1,000,000,000 because I don't think that's helpful. But I think multiplying out by 1,000 actually helped me in the first part. So I'm going to do it here. Instead of saying 0.12 thousand vehicles per year, I'm going to multiply it out by 1,000. So we're going to get about 120, and it's a rate of change, so it has to have 2 units, vehicles per year. So what's happening? In 2015, the number of vehicles with warmers is doing what? Is it increasing or decreasing if we got a positive 120 for our answer? There's our slope at that instant. Positive slope means it's increasing. In 2015, the number of vehicles with pizza warmers was increasing by 120 vehicles per year. So in 2015, there were about 1,000 vehicles with pizza warmers, but in that year, it's expected that it was increasing by 120 vehicles per year. So even more in 2015.